Hello. Today's in our lesson, we're gonna go through some example of exploring linear regression. Okay, so let's begin with the example. A random sample of 14 sales staff for a very large company were given a creativity test. Scores range from 0 to 20 points, with higher score indicate greater creativity, and was evaluated on sales growth performance. Higher scores indicate better performance. Right? So you are asked to explore and model the relationship between two variables with the goal of using the creativity score to predict sales growth performance. Okay. So here, notice that I underline predict sales growth performance, right? Using creativity score to predict sales growth performance. Okay, I'll tell you why I do that. Right. Okay, in this regression analysis, the variable creativity score played the role of blank variable. Now, for linear regression, when you analyze in linear regression, it is the study of relationship between two quantitative variables. Okay, so they are response variable, or sometimes we call dependent variable y, right? It's measure the outcome of the study. And explanatory variable, we call it independent x, or variable x, is thought to explain the changes in the response variable. Okay, so we use x to predict y, right? We use x to predict y. Okay, so here, if you go back to this example, so here, if you go back to this example above, can you tell me, can you tell me what are the two variable here? What are two variable here, right? So again, statistic is very wordy. So the trick here is you're gonna be able to focus on certain things, right? Just highlight certain things that keep that help you answering the question. Okay, so here I see, let me highlight something here. Samples of 14. I don't know I'm going to use it, but I'm just going to highlight for now. I'm going to highlight for now. And I see what a random sample of 14 sales staff for a very large company was given a creativity test. I'm going to highlight that too. Maybe highlight in red, right? Creativity red, creativity test. And that will be the score range. And was evaluate on self-growth performance. We use the creativity test to evaluate the self-growth performance. See, we use that to predict the self-growth performance. And remember what I said, we use x to predict y, right? So the question here, the variable creativity score plays the role of the blank variable. I'll give you a second to answer that question. Okay, here you have some choices. Here are your choices. Is it response? By the way, response is your y, or is it x? And confounding variable. I'm not going to explain it today, but sometimes they call it lurking variable, that variable that we don't want it to be in the data analysis. Okay. All right. So remember, I say that we use x to predict y, right? And remember, x is explanatory, y is response, right? So we use we use creativity score to predict the sales performance. So creativity score will be the x, right? X, that's the variable that we use to predict the outcome, right? So it's x, so therefore it's explanatory. B, right? B. There you go. That's your answer, right? And because we use that to predict the cell growth performance, that's what I underlined in the beginning. Okay. All right. Okay. Now, when it comes to linear regression, we cannot not having a scatter plot. It's very important that you look at the scatter plot before you go into the analysis, because you want to see the pattern. You want to see the pattern. Is that linear regression or it's not, right? Because if it's not linear regression, you cannot use linear approach to solve that problem, right? So here are some examples of the scatter plot, right? As you can see, the first one, A and B, they are linear scatter plot, right? How do I know that it's linear? Because I can draw a slope here. Draw a slope here, right? All the points are random, and they just kind of had that linear pattern to it, right? As opposed to C, D, and E. Look, C is like a cluster, right? It's like a cluster. So that's not linear, right? That's not linear. That's a whole different equation, right? And DE look like a parabola, right? Again, that's not linear. That's the second degree, right? That's not linear. So CDE, they're out of the picture, right? They're not linear. Therefore, scatter plot is really important when it comes to linear regression analysis. You're gonna know, you have to know what kind of data you have, the distribution you have before you actually get your hand dirty, right? You don't want to waste your time and doing the wrong thing. Okay, when you look at the scatter plot, there are 4 things that you should get out of it, right? First, the form, is it linear or not? So there you go, you look at the form, is it linear or not, right? Basically, you're just eyeballing it, right? If it's linear, then great, right? You can move on with your analysis. If it's not, then you just stop it right there. Or if you know a different type of analysis, use it, right? But not linear, right? A direction, is it positive or negative? So you're going to look at the slope, right? Is it positive slope or negative slope, right? How about the strength? Is it weak, moderate, or strong? Is your slope is very steep, or it's just kind of horizontal-ish, right? Right. The point is kind of horizontal, or is it very steep? If it's steep, then it's strong, right? If it kind of horizontal, is a bit lean to the horizontal kind of form, then it's weak to moderate. Okay. Outliers. Is there any deviation from the overall form? So if you look at, for example, if you look at this guy right here, if I have this, maybe I'll make a little dot right here, that would be my outlier, right? It's kind of alone by itself, right? Not together with the rest, right? So that will be your outlier, the point that's kind of deviate from the rest. Okay, so that's 4 things that you should be able to get out of when you look at the scatter plot. Okay, form, direction, strength, outlier. So let's go back to the example that we have. So remember the example that we use creativity score to predict self-growth. Self-performance. So here is its scatter plot. So this is scatter plot. Is it linear? Yes, right. It is linear, right? I don't see a ball or a parabola or some kind of funny looking pattern. It's kind of randomish, right? And have a direction of kind of moderate positive, right? It's kind of have a positive direction, right? Positive direction. So the direction is positive association. Strength is moderately strong, it's not very steep. So we say moderately strong. Outlier, I don't see any outlier, right? I don't see any point that kind of deviate from the rest. So no apparent outliers, no apparent outliers. So that's how you describe a scatter plot. Okay, so back to the same example. Now we're gonna do some math. One employee in a study scored 16 points. Remember those creativity test is range from 0 to 20, right? Remember in the beginning, it say range from 0 to 20. So one of the employee have a creativity score of 16 points and had a self-growth performance score of 100. What is the value of residual for this employee? Show all work and include units. Okay, so here is some vocabulary we have to learn. All right, we have to learn. So what is 16? What is 100? First of all, you're gonna recognize what are those numbers, right? Again, statistic is very wordy, so you're gonna pick your focus carefully. So first of all, I see 16 point, score 16 point. This means I know that my x is equal to 16. Remember, x is represent the creativity score, right? And y is the cell performance, and they perform. Maybe I'll highlight in green. the growth performed is 100 points. So this means, oops, sorry about that. Where was I? Right here, right. So that means this 100 right here, that's my y, which is equal to 100. And what is the residual? What is the value of the residual? What is the residual? The residual is the difference. The residual is the difference between what is actually observed and what is our regression equation predict. Right? So here, that value, the green value, y equal 100, that's the actual observed. That's the employee's actual performance score, right? Performance score. Now, what about the value that we predict for that employee, right? So determine the regression equation. This right here, this is predicted. This maybe out here. This is the predicted equation, right? Predicted equation. It has a form because it's linear. It has the form y equal mx plus b. Remember that linear form in math? And because it predicted equation, I wanna differentiate from the green one. I'm gonna denote it y hat. By the way, the green one is called the actual observed y value, and here is the predicted y value. The y hat is the predicted y value. It's predicted y value. Okay. Oops. Maybe I'll keep it with red. Predicted y value. Okay. So first of all, you have to figure out that equation. What is your m? What is your x? What is your b? Plug it in, right? And then you find out what's y hat, right? And use the regression equation to predict the response. So that's the part two. Part two is that's what I just said, right? Figured out to plug in the form, plug in the number. That's all the number two said, right? So plug in your values m, x, and b. To find out y hat. Step three is find the difference from the actual observation. So step three is you want to find the difference from the actual observed. I mean, you take the actual observed y, maybe I'll do in green here, your actual observed y, subtract your predicted y, which is we denote y hat. How do I get the y hat? Again, from there, right, from there. Okay. And they denote the residual is E. Look at that, it looked like an epsilon to me. All right, so that's the step that you have. You have to determine what is the regression equation, plug it in, find out what's y hat, and then find the difference. Okay. Okay, so let's do that. Now, your professor will give you all the information. I don't know how they're gonna give it to you. Maybe using Excel, or give it to you in the problem, which is you have to figure out which number is mean which, right? Here I'm showing you the software R. I don't think you ever gonna use this at OCC, but I'm just want to show you how do I construct my linear regression equation. Okay, that y hat equal mx plus b. So I need what? I need slope. I need slope, and I need the y-intercept, right? Y-intercept. Y-intercept. So here, 78.8461. That's your y-intercept. That's b, right? That's b. So I have one of them. That's b. Here is the slope of our example. That's creativity. So creativity. That's the slope. That's m. That's m. And what is x? Well, x, they give you right here, right? Like the blue one right there, x equals 16, right? So all you have to do is plug in all that information and find out what is y hat, right? So when I plug it in, y hat equal mx plus b. Sometimes they show here y hat equal mx plus b. Now, in a book they use b naught as b naught is the y-intercept, I'm sorry, the y-intercept, and b1 is your slope, okay? But whichever one you use is fine, all right? So again, our y-intercept is 78.8. Like we look at the outcome of the software there, right? And the slope is 1.7. It's positive slope, right? Plug it in. So that's step one. That's step one, the regression equation, right? Now we plug it in. We know the value of x is 16. We plug it in, and we got y hat is roughly 106. So that's your predicted y, right? That's the predicted y. Predicted y. Predicted y value. And we denote a y hat, right? We denote it's y hat. Okay. Once you have that, all you have to do is take the difference from the actual observed, right? Remember, actual observed, the green one, which is 100, right? 100 minus 106 is roughly 6, negative 6, right? Roughly negative 6. So this is what this means is that you kind of over predicted this person sales performance, right? His actual, the employee actual sale performance is 100. However, you predict is 106. So you over predict, right? So the residual, the difference is 6 points. Okay, that's all it is. That's all it is about how to calculate the residual. Okay. All right, I hope this is helpful, and thank you for watching.